Hey everybody, today I'm excited to introduce you to Companion Course Lesson 6, which aligns with Mission Objective 6 of the Artemis Roads 3 National Student Challenge. The guiding question for this lesson is, how can we design, test, and refine a rocket that is safe and reliable enough to transport human crews to and from the moon? This is the 6th of 8 lessons in the Companion Course and is part of the unit Bringing the Mission Home. This lesson follows the 5E instructional model, and in this video, I'll briefly summarize each phase. Okay, starting with the engage phase, students will explore how NASA tests its rockets to ensure they're safe and reliable enough for human space travel. They're going to learn about Commander Munikin Campos, which was a dummy astronaut that was used to test the Orion Crew exploration vehicle aboard the Space Launch System rocket during the Artemis 1 mission. Students will also create their own test dummies, which they'll use later in the lesson with their water bottle rockets. They'll discover that Commander Munikin Campos was actually named after Arturo Campos, who was a key engineer during the Apollo era, and then they'll name their own test dummies after someone who has inspired them. For creating the test dummies, we recommend using a Pringles chip or another similarly fragile item that is small enough to fit inside the crew exploration vehicle they're going to design that will fly aboard their rocket, but is fragile enough that it gives them a nice challenge to create a rocket and exploration vehicle that has a safe landing. In the explore and explain phases, students are going to dive into the essentials of successful rocket design. In particular, they're going to learn about the concepts of the center of mass and center of pressure, which are fundamental for designing a stable, straight-flying rocket with fins. To gain hands-on experience, the lesson introduces activities where students build simple rockets using wooden dowels or sturdy straws and paper. Clay or similar materials are also going to be needed to adjust the mass along the length of those rockets. And the final activity in this phase involves actually launching these rockets indoor using a slingshot mechanism and observing their flight. Students should record their observations in a science and engineering logbook, which hopefully will help them later as they develop their water bottle rockets. In the elaborate phase, students are going to use the engineering design process to improve on an initial water bottle rocket design. This is the portion of the lesson that really starts overlapping with Mission Objective 6 of the Rhodes Challenge. NESB is providing these water bottle rocket launchers to educators that sign up a challenge team, and these launchers are also available as a companion course supply loan for educators who complete a professional development workshop. Rockets can be made from 2-liter soda bottles, and students will add fins, a nose cone, and then distribute mass appropriately along their rocket. They're also going to design a crew exploration vehicle or a little thing to put their Pringles chip in, and hopefully it will keep that Pringles chip or that dummy astronaut safe during the flight. Some students may create that capsule and it'll just stay under the nose cone during the entire flight, while other groups of students may choose to eject that capsule and have it land separately under a parachute. Either is okay, but ultimately the students are going to come up with their own design and test and refine them over several launches during this part of the lesson. In the evaluate phase, students are going to be testing their final designs to prove that they can be launched 3 times in a row, reaching at least 50 feet in altitude while keeping their dummy astronaut safe. They're going to document their launches in their science and engineering notebook, and students' teams that are part of the challenge will also need to document the development and the final results of their water bottle rocket and crew capsule designs in their mission development log. If you want to extend this lesson, the extend portion gives links to some additional resources, including another NASA activity that's more focused on the crew exploration vehicle, in particular, designing one that can land in water, like NASA often lands its crew exploration vehicles. And then there's also an additional activity where students can simulate their water bottle rocket design using an online software program called Open Rocket. This lesson aligns with several science and engineering practice standards, including developing and using models, planning and carrying out investigations, analyzing and interpreting data, and constructing explanations and designing solutions. The NGSS content standards for this lesson fall under engineering, technology, and the application of sciences. This is a pretty long lesson, so educators should plan for at least 7 hours of in-class activities to complete the full lesson. If that's too long for your classroom, there's lots of ways to shorten it. You can skip the engage portion where they're learning about Commander Munikin Campos. You can take the explore phase where they're learning about the center of pressure and center of mass, and just do that as a demonstration in front of the class rather than having the students do the activities. And if your students aren't participating in the Artemis Roads 3 challenge, you don't have to do a water bottle rocket. You could have them build and design a foam rocket using a kind of a shorter NASA activity that can be completed entirely indoors. Really, the goal for this challenge, or for this lesson, is to make sure that students engage with the engineering design process, which means they are developing solutions to iteratively improve on an initial rocket design, and they should be documenting their results along the way, either in a notebook or the provided engineering design process worksheet. Okay, we hope that this video inspires you to dive into the full lesson and explore the associated Artemis Roads 3 mission objectives on our website. Thank you.